Hi, in this video, I'm just going to show you a really quick process for how to determine the amount of excess reactant after you determine your limiting reactant and your excess reactant. Here's an example of a limiting reactant problem. I'm going to walk you through it, and then I'll show you how to find the amount of excess for this particular problem. So in this question, we're given 100 grams of the copper nitrate and 100 grams of the sodium hydroxide. Okay, and anytime you're given two amounts of a substance and you're looking for a product, then we are looking at a limiting reactant problem. And if you look further down in the problem, so if you scroll down on your paper and you go to part C and D, in part C, you'll see that we're looking for the amount of copper hydroxide. We're looking for the percent yield, theoretical yield and percent yield of copper hydroxide. And so that means when we find our product, we're going to go to copper hydroxide. Now, we could do two stoichiometry problems and just go over to sodium nitrate. But then once we figure out our limiting reactant, then we would have to do a third stoichiometry problem. And we really don't want to do a third stoichiometry problem. So because we need to solve for copper hydroxide in part C, it's going to make our lives a lot easier if we just go to copper hydroxide with each one of our given grams. So we add 100 grams of the copper nitrate. And this is just a standard stoichiometry problem. The only difference is that we have two reactants. We're going to do each one at a time. Copy paste your grams of copper nitrate because we want it to cancel. And then we're going to go to moles. So moles goes on top of copper nitrate. These have to be the same. They have to both be copper nitrate. This now lets us cancel grams. One will always go with mole, unless it's the mole-to-mole ratio. And grams, when we add it up off the periodic table, I usually do the NO3, double it, and then add the copper. So I did 16 times 3, I added 14.01. And then I took that number and I doubled it and I added the copper. And that gave me 187.56. Okay, next up, copy and paste the moles of copper nitrate. Okay, so put that on the bottom so it cancels. Okay, now once you're at moles, we can go across our bridge. Our bridge is our mole-to-mole ratio. And so our bridge is what lets us go from one substance to another. And the substance you want always goes on top. We want copper hydroxide. And we have one copper hydroxide, and we have one copper nitrate. Just a 1-to-1 ratio. Okay, and then last step, copy and paste this. And if you need a refresher on this, these videos are located on Google Classroom. So this is copper hydroxide, moles of copper hydroxide. We want this to cancel. And we're looking for grams. So when it asks for yield, sometimes it could be moles, sometimes it could be liters. Generally, that's going to be grams. So we're looking for grams of copper hydroxide. Okay, one goes with mole. And copper hydroxide, 16 plus 1.008, so 17.008. Double that number because there's a 2 outside the parentheses, and then add in the copper, and that gave me 97.561. Okay, and then to solve, you take 100 times 97.561 divided by 187.56. So multiply the numbers on top, divide the numbers on the bottom. You really don't need to worry about the ones. And this gave me, I ran out of space, but this gave me 50.2.02 grams of copper hydroxide from the copper nitrate. Okay, next up, we're going to take our 100 grams of sodium hydroxide. And set up our fraction, copy, paste. Go to moles. These have to both be NaOH. One goes with mole. When I add up the numbers off the periodic table, I get 40. Okay, next step, copy and paste the moles of NaOH. And we're trying to get over to the copper hydroxide, just like we did with the copper nitrate. So we're trying to get over here, so we need to use a mole-to-mole ratio as well. And we're looking for moles of CuOH2. Okay, the CuOH2 has a coefficient of 1. The NaOH has a coefficient of 2, so those cancel. Okay, last step, copy and paste the moles of copper hydroxide because we want it to cancel. And we're looking for grams of copper hydroxide. One goes with mole, and then we add this up, we get 97.561. We already did this up above, so once you get to this part, it's a little bit easier because you've already done the work. Okay, 100 times 97.561 divided by 40 divided by 2 gives you 122.0. Okay, the smaller of your two answers is called your theoretical yield. When I did that analogy of the cookies, my eggs limited the batches of cookies that I could make. So the eggs made fewer cookies. And so this is my smaller amount. This is my theoretical yield. Theoretically, it's the most we can make given our amount of copper nitrate and sodium hydroxide. And the smaller number, the theoretical yield, always comes from the limiting reactant. So my limiting reactant is the copper nitrate. And just beware, when I ask for a limiting reactant, it has to be a reactant. These are reactants on the left. These are products on the right. So you would never pick one of these as an answer. We want a reactant. Okay, a lot of times I abbreviate this LR for limiting reactant. All right, and then down here we have the one that makes more is our excess reactant. We have more than enough of it. So this would be like our flour and our sugar in our cookie analogy. Okay, so now we have here, we have our theoretical yield. We have our limiting reactant labeled. We have our excess reactant labeled. Okay, next up, we're going to go ahead and find our percent yield using this information. Okay, so it's whatever you get in the lab, divided by our theoretical yield that we found up here. So that was from the limiting reactant. We had 52.02 grams times 100 because we're finding a percent. And this gave me 96.1% yield. So once we have identified our percent yield, now we're going to go ahead and figure out how much excess we have. So what we know is this. We know we were given 100 grams of both. But because the NaOH was excess, that means we didn't use all 100 of the grams. We only used a portion of the NaOH. And something that will help you is knowing that the limiting reactant is the decider. it's kind of like your eggs. It determines not only how many cookies are made, or in this case, copper hydroxide, but the copper nitrate also determines how much flour you need, or how much sugar you need, or in this case, how much sodium hydroxide you need. So we're going to use our eggs, our copper nitrate, to find out how much sodium hydroxide is going to react with it. So we get to do a third stoichiometry problem. Okay, so for this problem, it's a little bit different because we're starting with one reactant, and you're always going to start with the limiting because it's the decider. So we're going to start with our limiting reactant, which is our 100 grams of copper nitrate. And we're going to find the grams of NaOH that will react with it. So we're going to go from here to here. So we're going to do this stoichiometry problem. Okay, so set up your fraction, copy paste. Go to moles. One goes with mole. We already added this above. And so in the first part of the problem, we got 187.56 for this. Okay, that cancels our grams. Now we're going to copy and paste the moles. And this is where we go from copper nitrate over to sodium hydroxide. We're trying to find the amount of sodium hydroxide. And we look at our balanced chemical equation. We're using these coefficients. So copper nitrate is 1, sodium hydroxide is 2. So it's 2 over 1. And then we need to copy and paste the moles, NaOH. And we're solving for grams of NaOH. One goes with mole, and we already did this work as well. We said this was 40 grams. All right, so when we calculate 100 times 2 times 40 divided by 187.56, we determine that 42.65 grams of the given 100 grams of NaOH reacts with the 100 grams of our limiting reactant, the copper nitrate. Okay, so long story short, this would be like the amount of flour that combines with our eggs, or the amount of sugar that combines with our eggs. So you're going to take the total grams of NaOH. So we had 100 grams total sodium hydroxide. And we're going to subtract the grams that reacted with the copper nitrate. And that's going to give us the grams of NaOH that is unreacted. It's in excess. Didn't get used up. So that leaves us with 57.3 grams. Okay, so these are your steps. If you look at what we did, you need to figure out the limiting reactant. You need to figure out your excess reactant. You need to do a third stoichiometry problem and go from the limiting, which in this case was our copper nitrate, to our excess reactant. And that's going to tell us how much of our excess reacted with the limiting. subtract it from the total amount of your excess reactant provided, and that's going to tell you how much is in excess, how much was not used up. Okay, this next question here on the back, I'm not going to walk you through it, but I am going to tell you what the answer is so that when you do it, you can figure out the answer. Okay, so for this one, for D, you're going to figure out the amount of excess. And so your final answer for part D is going to be 25.2 grams of your excess reactant. And in this case, what we have here is we have excess NaOH again. Okay, so you're going to do your stoichiometry. You're going to take your limiting, go to your excess, take the total grams of NaOH, subtract the grams that reacts, and that's going to give you this final answer here.